exciting. So in this lecture, we're going to do the third of our tricks. Oops, I need to change that 2 to 3. Okay. And in this one, we're going to integrate e to the x, cosine of x dx. Why I like this trick is actually that it kind of focuses in on the fact that cosine of x, if you take the derivative twice, you more or less get back to cosine of x. And this is a very important property of both cosine of x and sine of x, which make them actually show up in a lot of circumstances where you have differential equations. Because if somehow or another, when you do something twice, you want to get back to a similar thing, then cosine of x or sine of x are great functions for this. I think this is why they're kind of prolific in some sense, or ubiquitous. That's one of my favorite words. They kind of show up in a lot of places. They describe some nice kind of motion like this, like a wave motion, which shows up in a lot of circumstances. They also just are functions that, yeah, as I said, these kinds of differential equations, they solve really nicely. So it gets you used to this fact. It's also just kind of a cute trick. So here we go. So we're going to end up taking, so this is going to be my u. So my u is going to equal e to the x. We know that the derivative of e to the x is e to the x. So my du is going to equal e to the x dx. And then my dv is going to be cosine of x dx. And my v, so I need to take the antiderivative here, so I'm just going to get sine of x. Okay, so now what we want to do is we want to actually try to integrate this. So we're going to integrate this the first time. And in each step, I'm actually going to rewrite the integral, and you're going to kind of see why at some point. So I'm going to take the integral of e to the x cosine of x dx is going to equal, so I need my uv. So I have e to the x sine of x. And then I have minus the integral of, and then we have v du. This looks like this isn't much better for us, except that it's going to turn out that this is going to be, this is where it's kind of a little bit of magic is going to happen. And great. Okay. So we haven't really integrated that yet, so I'm not going to put plus c. Now what I'm going to do is I'm going to do integration by parts again. And I'm going to kind of highlight that there's a kind of consistency. So if you want this to work out correctly, you don't want to undo things. You actually kind of want to keep your columns looking almost exactly the same. So the first one are going to be the e to the x ones. The second one are going to be the ones that involve cosine or sine. So I'm going to kind of emphasize that here. Okay, so this is going to be my u, and this is going to be my dv. And then you can just see how nicely this works out here, that u equals e to the x, du equals e to the x dx. So the first column looks exactly the same, and now for the second column, it's only going to look a little bit different. My dv equals, so now we just kind of swap that we have sine of x dx. And then my v is going to equal, sometimes I'm going to use the same label here. That's okay. Sometimes people also do this as w and z, but I want to do it like this. So I'm going to have my v is going to equal, and then this is just going to be negative cosine of x. Okay, great. So as I said before, we're going to do this like each time. I'm going to write this side because we're going to want to be solving for something. So we have e to the x cosine of x dx equals, we're going to leave this part alone. And now this is very me, then I'm going to put big parentheses here. We're going to do this entire integral inside these parentheses. Okay, so I need my uv. So I have my e to the x times minus cosine of x. And then I want my minus the integral of v du. So I have my minus cosine of x. And then my du here, which is e to the x dx. Ah, now we look like we're in business, right? Because now this is going to look like something over there. So we can just solve for it. Oh, 3 minuses. Thought we were going to be missing a minus. Okay, so let's just kind of write this again. So I have the integral of e to the x cosine of x dx equals e to the x sine of x. Now we're going to be very, very careful because there's a lot of minus signs, plus e to the x cosine of x. Okay, there's a minus, minus, minus. So that gives me a minus the integral of, and I'm just going to swap these so that they look in the same order as over there, minus e to the x cosine of x dx. Now we really believe that we're in business because we can just bring that over to the other side. So I'm going to go ahead and do that. And I'm going to get 2 times the integral of e to the x cosine of x dx is going to equal, and then I can, if I want to, I can pull out an e to the x there. It just kind of makes it a little bit nicer. So I get e to the x times sine of x plus cosine of x. And now I kind of check, and this was the integral that I wanted all along. So if I just divide by 2, I've got it, and I'm done. Okay, so this integral is going to equal, so I have e to the x sine of x plus cosine of x all over 2. Okay, and I'm done. That was exactly what I wanted all along, so I can put a big box around it. Oh dear, that was not what I meant to do. Okay, so what's going on here? It's again just the fact that differentiating or integrating cosine or sine twice actually almost gets you back to the same thing. And that's a really good property to know. It's can often help you solve problems. And just to keep yourself super organized. So the way that this one kind of works, I just, I just did my integration by parts. Notice when looking at this, this column looks exactly the same. This column looks very similar. Don't swap them or you end up undoing it. Students sometimes do that. The other thing is just to make sure that you put parentheses when you've got the integral there so that you don't make any mistakes. It's common at least to mess up the sign on things, and this doesn't work if you mess up the sign. And then other than that, right, we just keep track of how many minus signs we have with all of our parentheses. And then in the end, we're just able to solve for, we have the integral of e to the x cosine of x on both sides. We bring it over so we have 2 copies of it, and then we get e to the x sine of x plus cosine of x. And so we can just divide that by 2 and we get our integral. It's a fun trick. It's really a lesson in how cosine and sine work and the fact that you can integrate something quite complicated using integration by parts. So that's kind of fun to actually see. Okay, so I hope that was helpful. And I will see you in the next lecture.